Hey, Math 30-2s. I'm just going to do a quick little recap on how to use your calculator to do certain things that you need for this chapter and future chapters, such as finding maximums, minimums, the zeros, such as the x-intercepts of a graph, the y-intercepts, tracing the graph, like if you just want to find very particular things. We're going to be doing this in two series. We're going to do it one in TI-84, or I'll be using one for Desmos as well. A complete legit way of doing these kind of questions. It'll be just the two videos on how to do the same functionality for both of those. Okay, so let's get started with this one. So I just want to quickly I'm just going to type an equation in. So if you haven't done so already in a long time, you may want to clear your calculator. You can see at the bottom of the screen what I'm pressing here. Second plus gets me to this screen. So I can do a quick little reset. And so I'm going to scroll over here to all and hit memory and then reset. So it should say mem cleared at the end of that. Okay. Okay. So sorry about that. I'm going to just clear that out. Now what we're going to do is we're just going to go and input just a random function here, so we can just do a few things with it. So let's just put in a typical graph here. I'm going to produce in factored form, so I know that there's very specific x and y intercepts here. Okay. So there's my equation. Can't really see too well, but I'm going to show you what it looks like in the graph here. So I'm just going to go graph. You see there's my graph there. You can't see the top of it. You can't see the bottom of it. But this is what the equation looks like. So at the top of the screen there, you can see what I typed into y1. So I want x minus 4, bracketed x plus 2, bracketed x minus 3. So that's going to give us this kind of shaped graph. But that's not too important. It's just worried about, I just wanted to create a graph that would see some x-intercepts here that we may want to try to find. There's this possibly a y-intercept there, but we can't see, so we're going to do some zooming as well. So most of the time, what you're going to want to do is first of all, you want to go zoom number 6. Zoom number 6 gives us the standard zoom. So if you fiddle around with the zoom in the window and you're like, I can't see my graph, it's best to just start off with zoom number 6. So zoom standard there. All right. So right now, what you could see on this shape, you could see here there's a bottom, we call that a minimum on the graph. We have a graph that seems to be going upwards. You can't see the top of it, but might be coming back down and then going back up. So this is a typical cubic graph. If you're watching this beginning polynomials, we haven't talked too much about what this shape of the graph looks like here, but that's okay. So what we're going to do here, I'm going to show you a few things. So let's say I want to find the maximum of this graph. So what we're going to do is we're going to either one of two things. You can go to zoom and hit zoom out. If you hit zoom out, it's limited because I had to hit enter there. So hit number 3, zoom out, and then hit enter. It's limited to how it looks afterwards because it's just going to take the whole thing and just zoom out in all directions. And you may not want to do that. So let's go back to zoom standard. So the graph looks like this. The side-to-side zoom looks just fine. I just want to get a higher zoom on the top here. So what I'm going to do rather than zoom is I'm going to hit window, and I'm going to go change the Y maximum because I want to see more of the top of the graph to something a little bit higher. So maybe 20 and hit graph. And that makes it a little bit easier. You can see the side-to-side hasn't changed. The shape looks a little bit better. I can't quite see the top, so I'm going to go back to window and increase it again and hit graph. There we go, that looks better. You can see the scale on the y-axis is all kind of messed up. That's because it's trying to put 30 ticks because the scale is 1. So it's going up 30, down 10, so it's putting ticks everywhere. So if you want to just reduce that number a little bit of ticks, you increase the number here to 5 or 10 or something. You can see it's a nice better. So this, every single one of these little ticks is 5, 10, 15, 20, 25, 30, etc. So there's my graph. Okay, goes up, down, and then back up. So I want to find some parts of this graph. So to find most of the things on a graph like this, you're going to be using second trace. Second trace loads up the calculation menu, and you're just going to deal with, in this case, from 2 down to 5, 0, min, max, and intersect. Don't worry about the bottom two, that's calculus, and the top one, I don't know what the top one's for. I'm not going to really worry about it too much. Okay, so what I want to find first, let's see what this maximum value happens to be. So I'm going to go second trace, oops, sorry, not form, second trace. I want to go to maximum here. Then it's going to ask me a few questions. All right, so the first question is going to be left bound. So what you want to do is you want to make sure your cursor, you can see this little cursor here, is left of the point you're trying to find. So right now it is left. I had to move it slightly there. Then as soon as I hit enter, you can see a little arrow pop up there. If you have one of the newer calculators, it'll give you some lines as well. The next question says right bound. So you just want to move right of the point we're trying to find. So we're trying to find the point up here. So hit enter. So we got another little arrow there. You just want to make sure the point you're trying to find is in between those two arrows. Hit enter, and then tells you what the maximum value is and when it happens, the X and Y values there. Okay, the same can be said for the minimums. So number 3, if I want to find a minimum of a graph, you go down to say this one down here on the bottom on the right. Move my cursor closer to it. Hit enter because it says left bound, then go over, right bound. You can see the 2 arrows. You just want to make sure that minimum value is in between those 2 arrows. And there, hit enter again. And then I have a minimum. Okay. A few other things you may want to try to find would be like a 0. So maybe I want to find where does it cross this x-axis here. So if I go second trace, a 0 is any of these x-intercepts, but they're going to follow the same questions again. So I'm going to go back up here. Okay, so I'm going to go over here, maybe too far. So I just want to make sure my cursor is on the left of that. So the same questions, the left and right bounds. So there's 1. Go to the right of it. I'm going to go there. And then my guess, I can put my guess a little bit closer if I want to. And it gives me a 0 of -2. I could do that for these other ones. You just have to make sure that when you do your left and right bound, you just want to make sure that you're not past the second one. You want to make sure you only have 1 0 between the 2 pieces. Okay, so that's how we find a 0. If I want to do a trace, if I want to find, say, this y-intercept here, rather than hitting second trace, just hit trace. There's your cursor. You can move it around all you want. All right. But if I want to go to a very specific spot, such as when my x values are equal to 0, you just hit 0, enter, jumps your cursor to that spot. So 0, 24 is on the graph. I can go anywhere too, anywhere that's at least on what I can see here. So I might be able to go trace 6. So it goes to me 648. That 6 is off my graph too. So what's there? 648. So I could probably trace to anywhere. I don't think I could trace to something that's off the graph. Yeah, so if it's off the graph in the domain range, so past 10 there, gives me an error. That's fine. If I want to see what 100 happens to be, I can go to my window. No, I have to go to first. Okay, I can go to my window. I can make this a little bit larger. Okay, then I can go trace 100. There's my value. See, it doesn't really matter if I can't see it in the Y, but as long as my X is within the window, that's okay. There you go. Now, if I want to see the table of this, so maybe I want to sketch this out pretty precisely, and I want to see the table of data, I can go second graph, and that gives me the table of data to look at, and I can scroll up and down. I can look at different values on that graph there, and there you go. Okay. Another useful thing is the intersection button. So say you had 2 graphs. Say I created a graph here. I'll just put a line as you go to 5 here. And I'm going to go zoom back to standard. So here. So I have my graph I had before. And now this new line here. And I might want to find out where does this line intersect with the other graph. So there's 2 graphs. Where do they intersect? So go second trace, intersect number 5. And because we only have two graphs, where's my cursor right now? I don't know where my cursor is. I can't see it. Okay, so here's my cursor. Because I only have two graphs, all I had to do for the first two questions where it says first curve, you just hit enter. Second curve, just hit enter because it just jumps between the two graphs. If you had more than one graph, you'd have to hit the up and down arrow. But I want to make sure I have the two different graphs here. So you can see my cursor's now on that line up there. Hit enter. And then the guess here is pretty important because you want to make sure that if you want to find, say, the intersection to the furthest left over here, just move your guess over to there. Something pretty close to it. Hit enter. And then it finds, as long as it says the word intersection, that's the intersection point. So if I want to find the next one, go second trace number 5 again for the intersection. And ask me the two questions, enter, enter. And then I just move my cursor to the other intersection points to find that. So that one there. So you can see intersection, there's my next one, my cursor's there. Okay, so hopefully that helped you out with at least trying to use these calculators to solve the question. My next helping video would be using Desmos to do the same thing. So I'll see you in that video. Bye.